Hello. In this video, I'm going to explain to you how to add and subtract binary and hexadecimal quantities, but first I will briefly explain what it means to represent a decimal number in binary and hexadecimal form. Binary is represented in ones and zeros only, and K represents the number of bits. In other words, the number of places that the number we are going to represent will take up, and the places are represented by 2 to the power of k minus 1 from left to right. In this case, there are 4 bits representing the decimal number 13. 2 to the 3, 2 to the 2, 2 to the 1, 2 to the 0, 2 to the 4 minus 1, all the way down. 8 times 1 is 8, plus 4 times 1 is 12, plus 2 to the 0 times 1 is 13. Hexadecimal numbers are a totally different beast with a few similarities and some numerical relations to binary numbers that will help us when I demonstrate how to convert from binary to hex and vice versa. But first, hexadecimal numbers are represented by powers of 16, and thus each bit k can only represent 16 minus 1 multiples of the power of 16 that is represented by said place. 1 through 9 are single-digit representations that need no substitute. However, 10 through 15 are two-digit numbers that do need substitutes. 10 is represented by A, 11 by B, 12 by C, 13 by D, 14 by E, and 15 by F. In this brief example, I provided you with a decimal number converted to hexadecimal number. There is a number of steps you can go through when deciding what hexadecimal representations you'll use. I'll go through them with you right now. First, estimate what power of 16 might be a multiple of that number. If it's less than 16, you've discovered the number of bits. If it's greater or equal to 16, you must go a power higher. So 61,289 divided by 16 to the 3 equals 14.963. Now this number is less than 16. So 16 to the third is our farthest to the left bit, meaning we have 4 bits. Now 16 to the 3 is represented by 14, or E. You times 6 to the 3 by 14, and you subtract that number from 61,289. Then you divide that number by 16 to the 2, and you round down, and that will give you 15, or F. And you just rinse and repeat until you have your number. I'm assuming most of you understand this already. I was just giving a brief review for those of you who might be rusty on the topic. But that is your final answer for converting that decimal number to this hexadecimal number. I'll now perform binary addition and subtraction. So you have 1, 0, 1, 1, plus 1, 1, 1, 1. 1 plus 1 is 2. 2 represented in binary is 1, 0. So 0, carry the 1. 1 plus 1 plus 1 is 3. 3 represented in binary is 1, 1. So 1, carry the 1. 1 plus 1 is 2. 0, carry the 1. And then again, 3. This is your answer, 11010. That's very straightforward. Now subtraction set it up the same way. One minus one is 0. 0 minus 1 is a negative number. We can't have that in binary, at least not with what we're doing here. Negative numbers in binary is 2's complement, which I may do a video on soon. But for this case, we're gonna borrow. When you borrow, you're borrowing a place over, so you need to represent that by 1, 1 in the place that needs borrowing. 1 minus 1, 1 remaining. 0 minus 0, 0. 1 minus 0 is 1, and 1 minus 1 is 0. 0, 1, 0, 1, 0 is your answer. Now you can check these by simply converting these back to a decimal number, which is very easy. They're 4 bits in the addition problem, so 2 to the 3, 2 to the 2, 2 to the 1, 2 to the 0. 1, 2, 4, 8. 1, 0, 1, 1, and 1, 1, 1, 1. 8 plus 2 is 10, 11. 1, 1, 1, 1. 8 plus 4 is 12, plus 2 is 14, plus 1 is 15, equals 26. Now, the next bit over would be 2 to the 4, or 16. So 16 plus 8 is 24, plus 2 is 26. This checks out, and this also checks out. You can do that separately on your own if you would like some practice. Hexadecimal addition and subtraction. Set it up in the same way we just did previously. Five plus 5 is 10, represented by 8. It's also useful to write the letters and what each letter represents, just for your own personal reference, in order to, be accurate in your adding and your subtracting. 3 plus 9 is 12, represented by C. F plus B, 11 plus 15 is 26. How do we represent that in hex? 16 goes into 26 one time. 26 minus 16 is 10. That equals 1. So this is the hexadecimal representation of F plus B. So A, carry the 1. 1 plus E plus A, 1 plus 14 plus 10 is 25. 25, similarly, is represented in hexadecimal like this. 16 goes into 25 one time. Remaining is 9. 1 times 9 is 9. So 9, carry the 1. Now I want to do a subtraction problem. Three minus D, or 3 minus 13, doesn't work, so you need to borrow. This 1 becomes a 0, and this 3 becomes a 1, 3 in hexadecimal. When you're borrowing, you're borrowing from a place ahead of the place you needed to borrow. Sorry, that's a bit of a tongue twister. So in hexadecimal, it becomes 1 and then whatever that number is. So it becomes 19 minus D, which is 13, which is 6, which can be represented simply by 6. Now, we need to borrow again because 0 minus C is a negative number and we can't have that. So D becomes a power down, or not a power down, but a representation number down. So D becomes C, and this becomes 1, 0 in hexadecimal, which just simply equals 16 minus C, or 12, equals 4. Can just be represented simply by 4. C minus 1 is 12 minus 1, which is 11, and 11 is represented by B. F minus 2, 15 minus 2 is 13, which is just represented by D. So D, B, 4, 6 is your final answer for this problem. Now, you can check these answers in the same way that you check your binary addition and subtraction answers, but obviously with powers of 16 that gets out of control almost immediately. It's too much to do in your head, well, for most people at least. So there's several websites online that will just give you the answers, but the reason I'm doing this video is to help you understand where those answers come from and help you actually perform these equations on paper without the aid of a calculator or a website, which is most likely how your test will be. Finally, I'm going to show you how to convert from hexadecimal to binary and vice versa. But first, hexadecimal to binary. Converting hex to binary, it is important to remember that for every one hexadecimal bit, there will be at least 4 binary bits. In this example, we have a hex number with 4 bits, so we will have a binary number that has 16 bits. Now, again, remember it's important to write down these letter to number representations in a column somewhere, just for reference for yourself, unless you feel comfortable with them to the point where you can just, remember them and give them as an answer immediately. I did that up here, but I just wrote it again. Okay, so the number I've provided is in hexadecimal form F E 9A. Now, to convert it to binary, like I said, there's going to be 16 binary bits, so A, represented in binary, A is 10. This place is 8, 4, 2, 1. So how can we get 10 out of this? Very simply, 8 plus 2 is 10. Now, the numbers will go the way I've written them, all the way up to 2 to the 15, but each divided section you're going to want to think of like this first section. So how do you convert the next bit, 9? Very simply, 8 plus 1. The next section, E, which is 14, how do you represent that in binary? Very simply, 8 plus 4 is 12, plus 2 is 14, and then 0. F is 15, represented in binary is 1, 1, 1, 1. So 1, 1, 1, 1, 1, 1, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0. That is this number in binary. Now, converting binary to hex recall that there are 4 binary bits for every 1 hex bit. So what if you get a binary number of bits of 13 bits, much like the example I've provided? Well, you will do this. Round the number of binary bits in the number that you are trying to convert up to the next multiple of 4. So we have 13 binary bits here. What's the next multiple of 4? We're going to add 3. That'll be 16. So 16 divided by 4 equals 4 hex bits. This is the number of bits that this 13-bit binary number will convert to in hexadecimal. Now it's useful to provide yourself with 16 blank spaces like I did here and fill the binary number you're trying to convert in from right to left. 1, 0, 1, 1, 0, 0, 1, 0, 0, 0, 1, 0, 1, 1, 0, 1, and then 1, and then just put zeros in the remaining places for placeholders, just so you remember that there is no actual value there. Now, like before, just think of each of these divided sections as 8, 4, 2, and 1. So 1 plus 4 plus 8 is 13, represented by D. 1, 2, 4, 8, 4. One, 2, 4, 8. 8 plus 2 is 10, plus 1 is 11. That's represented by B. And then simply just 1, because the rest of the numbers are 0. 1B, 4D. That is this binary number in hexadecimal form. Now, like I said, these are still large powers of 2, but we're just thinking of them in small powers so we can simply add them up and convert our binary number. Just remember that this is strictly for converting them. These will always be large powers of 2 when you're talking about a 16-bit binary number. And 4 bits in a hexadecimal number is also an extremely large number because we're talking powers of 16. But that is adding, subtracting, and converting. Thank you again for watching. Please comment with any questions you may have or suggestions for future videos. Take care.